Hello, I'm David Shaw. I'm here to further introduce the Genix Test Unit, which is our automotive production sub-assembly test unit. As we've covered during previous videos, automotive sub-assemblies such as bumpers and spoilers typically contain many electronic components, and it's important to ensure that the correct components have been fitted, fully connected, and that they match the specified engineering revisions for the vehicle program. The Genix Test Unit was made to help distinguish between components that are electrically different but otherwise indistinguishable to the naked eye. For example, these two components here. These two sensors look the same, but they are electrically different. In a production environment, it's possible the two sensors may be confused and therefore fitted into the incorrect bumper or spoiler model. During this video, I'm going to show you how to use the Genix Test Unit to distinguish between those two types of sensors and many other components typically found in bumpers and spoilers. Normally the Genix Test Unit would be housed within the electrical cabinet of the assembly station, but since we're in a lab, I'll show you how to do it within a lab environment. To install the unit, firstly you would secure the unit itself within the electrical cabinet using the bolts provided. Connection to both the PLC and the device under test is achieved via screw terminal. Power for the Genix Test Unit is provided via a 24-volt connection from the assembly station. Firmware is provided in the unit already, however upgrades can be provided via the CAN port should the Genix Test Unit be required for further vehicle programs. Each reconfigurable I/O channel is permanently assigned to a specific component in the harness, so once the Genix Test Unit is wired, there should normally be no reason to change it again during the course of a vehicle program. So, additional test requirements can be serviced by either firmware upgrades or additional Genix test units. So now we can talk a little about how the test procedure works. Prior to the start of the test, the PLC instructs the Genix Test Unit using 24-volt digital outputs which family of components is due to be tested. After that, it sends a further signal that says which engineering provision within that family you're looking for. Components such as lights and antennae that don't ever change need no configuration from the Genix Test Unit. Following this configuration sequence, a further digital input is sent to the Genix Test Unit that causes a test to start, and within 2 or 3 seconds, tests on all components within the harness are complete. Let's proceed with a practical demonstration. On the table, we have the Genix Test Unit. We've got a pair of sensors ready for connecting to the harness for testing, alongside all the other components on the harness, of course. We also have a ZIF connector, which is very important when connecting the unit to the harness, as it's designed to reduce wear and tear to connectors, and it also allows easy replacement of test fixture connections. And finally, we have an application built using our real-time interface creation software VisualConnect, which receives test results from the Genix Test Unit. Of course, in a manufacturing environment, these test signals would be sent directly to the PLC. Now we've explained what all the parts of the Genix Test Unit are, we can see how it would be installed in a manufacturing location. To fit the system together, firstly we attach the ZIF connector to the Genix Test Unit. This will give connectivity to the device under test. We then connect the PLC I/O to the PLC in similar fashion, and finally we provide power to the Genix Test Unit. Once this is done, we can now test all of the components fitted within the harness. To do so, signals are sent as before from the PLC to the Genix Test Unit, and then each of the 16 measurement I/O channels from the Genix Test Unit are observed by the PLC. As we said before, the PLC sends 2 signals to the Genix Test Unit. The first indicates the type of sensors being tested, for example AK or HP, and the second indicates the engineering revision that should pass the test. For example, either HP version C or any other type of HP sensor. As you can see, the GUI has delivered 2 test results for these 2 sensors. However, one of the test channels is reporting a fail even though a sensor is physically connected. This is because this sensor is of an incorrect engineering revision, in this case HP where it should be AK, and has not responded correctly to the LIN communicative test performed by the Genix Test Unit. So, if we replace one of these sensors with the correct engineering revision, i.e. AK, its test result will now change. So the Genix Test Unit can deliver this test functionality for every component attached to the harness for bumpers or spoilers across different vehicle models and different vehicle years. So that's it for now. Let us know if you have any questions via the email address sales@add2.co.uk. Otherwise, we look forward to hearing from you soon.